Right now, you're sitting still. You can feel it. The chair under you isn't moving. The room isn't moving. Put a coin on the table, and it stays exactly where you left it. This is the most convincing illusion you will ever experience. Because in the 5 seconds it took to read that sentence, you traveled 150 kilometers. And that is only the first layer. Start with the ground under your feet. The Earth turns once every 24 hours. That sounds slow, but the Earth is 40,000 kilometers around at the equator, which means someone standing in Ecuador or Kenya is being carried sideways at 1,670 kilometers per hour. That is faster than a passenger jet, faster than sound. If you could step off the planet for 1 hour, the ground would slide past you at Mach 1.4. Further from the equator, it slows down because the circle you are riding gets smaller. In London or Berlin, you are doing about 1,000 kilometers an hour. In Reykjavik, about 700. At the North Pole, you're not moving at all. You're just turning on the spot once a day. And you feel none of it. Not because it is slow, but because everything around you is moving at exactly the same speed. The air, the oceans, the building, the coin on your table. Motion you share with everything is motion you cannot detect. Hold on to that idea. It matters at the end. Second layer. Zoom out. The Earth does not only spin. It falls around the Sun on a loop 940 million kilometers long once a year. Do that arithmetic, and the number stops being intuitive. The Earth moves along its orbit at 107,000 kilometers per hour, 30 kilometers every second. Count 1 second. In that time, you crossed 30 kilometers. A large city, edge to edge, while sitting perfectly still. By the time this video ends, you will have traveled about 18,000 kilometers, further than the entire diameter of the Earth. And still nothing. No wind, no pressure, no sense of speed. Your coffee does not slide across the table because the table and the coffee and the whole planet are falling around the sun together. Here is the part that should bother you. For almost all of human history, nobody believed any of this. And they were not being stupid. They were being empirical. Look around. Nothing moves. Drop a stone and it lands at your feet, not 100 meters behind you. The obvious conclusion is that the Earth stands still. Copernicus published The Alternative in 1543. His critics had one objection, and it was a genuinely good piece of science. If the Earth really swings around the sun, they said, then over 6 months we view the stars from opposite ends of an enormous orbit. Nearby stars should visibly shift against the distant ones. That shift is called parallax. Go outside tonight, look up, and you will not see it. They were right that it must happen. They were wrong about the scale. The stars are so far away that the shift is real and almost immeasurably small. It took until 1838. Friedrich Bessel, watching a faint star called 61 Cygni, finally caught it. 0.3 of an arcsecond, roughly the width of a coin seen from 15 kilometers away. Almost 300 years passed between the claim that the Earth moves and the first direct measurement that proved it. The spin took until 1851, when Léon Foucault hung a heavy pendulum from the ceiling of the Pantheon in Paris and let it swing. A pendulum keeps swinging in the same plane. The floor beneath it does not. Hour after hour, the swing appeared to rotate. It wasn't. The building was turning underneath it. And for the first time, a crowd of people stood and watched the Earth spin. Every motion in this video is invisible to your senses and undeniable to an instrument. That gap is more or less the entire reason science exists. Third layer, and this is where it stops being comfortable. The sun is not a fixed point either. It is one of a few 100 billion stars in the Milky Way, orbiting the galactic center 26,000 light-years away. The sun, and everything bound to it, including you, is moving through the galaxy at 230 kilometers per second. 820,000 kilometers per hour. At that speed, you would cross the Atlantic Ocean in 24 seconds. But the galaxy is so large that even this barely registers. One full lap around the Milky Way takes 230 million years. Astronomers call it a galactic year. The Sun has completed about 20 of them in its entire existence. The last time our solar system passed through this part of the galaxy, the first dinosaurs were only just appearing. The Atlantic Ocean did not exist. Every continent on Earth was fused into one. That was one lap ago. There is one more layer, and it is the strangest. The Milky Way itself is moving. It is falling toward the Andromeda Galaxy, and both are being dragged, along with dozens of other galaxies, toward a concentration of mass a couple of 100 million light-years away. Astronomers named it the Great Attractor. But how do you measure the speed of an entire galaxy when there is nothing nearby to measure it against? You use the oldest light there is. The cosmic microwave background, the afterglow of the Big Bang, fills the whole sky in every direction. And because we are moving through it, it is not quite even. It is very slightly hotter in the direction we are heading and cooler behind us. A Doppler shift stretched across the entire universe. Measure that imbalance, and you get an answer. Against the light of the early universe, the Sun is moving at 370 kilometers per second, 1.3 million kilometers per hour. So, spinning at 1,000, orbiting at 100,000, circling the galaxy at 800,000, drifting through the cosmos at over 1 million. And you have not left your chair. Now the twist. Ask a physicist how fast you are really moving, and they will tell you the question has no answer. Not because we cannot measure it, because there is no such thing as absolutely standing still. Every speed in this video was measured against something. The ground, the Sun, the galactic center, the ancient light of the Big Bang. Change what you measure against, and the number changes. There is no cosmic ruler bolted to the center of the universe. There's no fixed stage that everything else moves across. Which means the person sitting perfectly still in a chair and the astronaut in orbit at 28,000 kilometers an hour are each, in their own frame, completely at rest. Both of them are right. Motion is not a property an object has. It is a relationship between two things. But relativity leaves us with one last idea, and it might be the best one. Space and time are not separate. They are one fabric, and every object moves through that fabric at exactly one speed. The speed of light. Always. Without exception. When you sit still, all of that motion is pointed through time. You're not moving through space, so you travel into the future as fast as it is possible to go. Move through space, and you have to borrow from the same budget. You trade a little of your motion through time for motion through space. That is why a clock on a fast spacecraft runs slow. It is not a trick, and it is not an illusion. It is the accounting. So the honest answer to how fast you are moving right now is this. Exactly as fast as everything else. 299,792,458 meters per second. Through space-time. You have simply been spending almost all of it on tomorrow. This channel takes one number that is impossible to feel and makes it visible. If that is your kind of thing, subscribe. There is a new one every week.